JMath.
In this video, you can practice a few random word sums for calculus, and you can pause the video here, try these three sums, and then let's do and mark it together, and then you can see how well you did. And we'll load another video with the more advanced surface area and volume sums that you also get a lot with calculus word sums. Question A, you can read the story up there. It's about a dam, and then they're opening the floodgates, and then they give you a formula. Question A. Calculate the average rate at which the depth changes in the first 3 hours. So remember again that word average. So I'm going to use m is equal to y2 minus y1 over x2 minus x1. In order to do that, I need two coordinates. So they're trying to hide the coordinates. So I know one of the coordinates has to do with a 3. Okay, so this one is going to have a 3 there because they're talking about 3 hours. And then the other one I will find if I just understand what the first 3 hours means. So that means it's from hour 0 to hour 3. So I just now need to get the two coordinates there and then do the gradient formula. So when I sub in 0 into that formula, I see it's just 28. Okay, and then they're saying the first 3 hours, so now I need to sub in 3 into the formula, and that tells me D is equal to 26. So remember, guys, if they say the first 3 hours, it is the coordinate at 0 and the coordinates at 3. Don't let them catch you out and you blank on this first question. So then I can say, therefore, the rate is equal to, I'm going to go 26 minus 28 over 3 minus 0. That answer would then just be minus 2 over 3, which would give me 0.66, but a minus. And this story is about meters and hours, so that is meters per hour. Question B, determine the rate at which the depth changes after exactly 2 hours. So question 1 was average, therefore I do the gradient formula, and question 2 is just the rate. So that is the derivative. So I'm going to get the derivative of D, which would then just be equal to a ninth times 2 gives me 2 over 9, and t to the power 1, minus 1 over 27 times 3, which gives me 3 over 27 times t squared. And now I will get the answer if I sub 2 into the place of t. So minus 2 over 9 times 2 minus 3 over 27 times 2 squared. And if I type that on my calculator, it tells me the rate is then minus 8 over 9, or I can put that in a decimal as minus 0.89 meters per hour. The following two questions have to do with speed, distance, and acceleration. Now, it's a bit unfair to people who don't have physics, but please study this screen that you don't get caught out. So you need to know anything that is connected with distances or height. If that's your original, then your derivative would be speed, and your double derivative would be acceleration. So if they ask for the maximum speed, I need to get the derivative equal to 0, but it's the derivative of the speed function, so the double derivative. So it gets complicated, but please study that and attempt these two questions. They don't come up too often, these types of questions, but you still need to be able to do them. Question 2. Victor stands on top of a building and throws a stone vertically upwards. The stone's height in meters above the ground at t time in seconds is given by that formula. Okay, so please don't mind my drawing skills. This is the story we're looking at. So if Victor is standing on top of the building, he throws the stone, and that formula tells me it's going to follow a parabola path till it hits the ground. Okay, so even though they say vertically up, they just mean up over the building. Question A, determine the initial height above the ground. Okay, so even though he's throwing it up, so from where he stands, it's still going to go higher, but he starts at the height of the building, not the height of the ground, because in story sums, that would be considered as 0 on your y-axis and x-axis. So we just need to figure out how high is the building. Now, if I look at the formula they gave me, and I can rewrite it as y is equal to minus 5t squared plus 30t plus 35. I know if I make all the t's 0, because they said initial height, so that means the start of this story. So then it is y is equal to minus 5 times 0 plus 30 times 0 plus 35. So therefore, what's the height above the ground? 35 meters. Question B, determine the initial speed at which the stone is thrown. Okay, so once again, initial means the time is 0. Now, if they talk about speed, if the first equation was height or distance, then speed would be the derivative of the equation. So if I get the derivative of h, it would be the speed. So in this case, it would be the 35 I'm not going to take, but minus 5 times 2, so minus 10t plus 30t, so that would just be plus 30. Great. Now, if I make t 0, then I would get the initial speed. So h derivative of 0 would then be minus 10 times 0 plus 30, and that tells me the initial speed was 30 meters per second. Question C, what is the maximum height the stone reaches? Maximum in all of these sums means the derivative is going to be equal to 0. So I can just take the derivative, make it a 0, and then solve for time in this case. If I take the 10t over, it would be 30 divided by 10. So therefore, after 3 seconds, it reaches the maximum height. They are asking me, what is the maximum height? That I get if I sub in 3 into the original equation. So h of 3 would then be equal to 35 minus 5 times 3 squared plus 30 times 3. Okay, so 35 minus, 5 times 9 gives me 45 plus 90, and that would give me 80 meters above the ground. So always check nicely with questions like this. Are they just asking for the time, so the x-axis, or are they asking for the actual value, because that would always be the y-axis, which I get from the original equation. Question D, how fast was the stone traveling? So how fast? Speed, so it's definitely derivative. When it reached a height of 60 meters, so height is the original one. So now I'm stuck with, I have two formulas I need to use. We're going to do it in 2 steps. First, we're going to figure out what was the time when it was 60 meters above the ground, and then we're going to use that time to figure out the speed. So let's start then by making the original equation equal to 60 meters. So 60 is equal to 35 minus 5t squared plus 30t. So that's a trinomial again. And I'm going to take everything to the left so that my t squared value is positive. So 5t squared minus 30t. If I take everything left, it means it's 60 minus 35. And that would then just be plus 25 is equal to 0. I'm going to divide by 5 everywhere. So that's minus 6t plus 5 equals 0. And therefore, it's t minus 5 and t minus 1 in my brackets. Therefore, it happened at t equals to 1 second, or t equals to 5 seconds. Now it's very important where the story and the picture comes in. So they are talking about 60 meters on the way down. So obviously that needs to happen after the turning point. So that is later in the story. And that's why I'm going to say the 1 second is not applicable and 5 seconds is the one that I'm going to use. The question was, how fast was it going? So I now need to take my 5 seconds and sub it into the derivative. So now earlier we saw that the derivative was just going to be minus 10t plus 30. And I know now I'm going to replace the t with 5 seconds. So let me just do that in the one step because I'm running out of space. So that's 5 seconds. So therefore, the answer is the speed when it was 60 meters above the ground on the way down is minus 50 plus 30. And that gives me minus 20 meters per second. Okay, now the physics students will find this as a normal sum, but to the rest of us, how can something go minus 20 meters per second? That just means when the story started, up was the direction where everything was positive, and down was a negative direction. So that just means 20 meters per second in the opposite direction of what I started with. But the answer is still 20 meters per second. I can just write the word downwards next to it, or down. Then I would get full marks. Question E, what was the speed and also the acceleration of the stone when it hit the ground? So in my little Picasso sketch there, that point there. So I firstly need to figure out what was the time when it hit the ground again. I'm going to do that by taking the original equation, so the height equation, and saying what was the time when height was 0. Yeah, now I can just solve again. I'm going to take everything to the left. 5t squared minus 30t minus 35 is then equal to 0. I'm going to divide everything by 5 just to make my life easier. And then I can solve this. So therefore, it's minus 7 in the one bracket and t plus 1 in the other bracket. So then I know the time was minus 1 second, which is impossible, or 7 seconds. Now I know I'm not going to take the minus 1 because time cannot be negative. And that is just in my little sketch if this parabola was to be completed that way, but then it would go through the building and it doesn't make sense. So remember, you need to find a way to link the math with the story. And don't let them confuse you. So minus 1 is not the correct time for this question. Now they're asking me for the speed and the acceleration. So speed, once again, we know it is the derivative is equal to minus 10 times t plus 30. In this case, we are looking for 7 seconds. So it would be minus 70 plus 30, and that would just give me minus 40 meters per second. That was the speed. Now they're asking me for the acceleration. And remember, the acceleration in the story sum with distances and speeds is always the double derivative. So just to make it easier, I'm just going to write the normal derivative first, and that was minus 10t plus 30. Therefore, if I get the double derivative, I am going to ignore the 30, and the answer would just be minus 10. The t goes away. So it doesn't matter what the time is in the story. The acceleration will always be minus 10 meters per second squared. Okay, guys, now they won't be too strict on the units you use with this because people who do not take physics will be at a disadvantage. So as long as you just get minus 10 for the double derivative, then it's fine. And why am I not subbing in 7 seconds in the double derivative? Because I don't have a t value anymore. Okay, so to answer their question, I could just say speed was minus 40 meters per second. Okay, or let's like the previous one, I can just say 40 meters per second down. And then acceleration was equal to minus 10 meters squared per second. Great, guys, that was question 2. I hope it wasn't too tricky, but Just study what is speed, distance, and acceleration, and then you'll be able to do these questions. Don't worry too much about the units next to it. You will get your marks for the numbers. Question 3. So like I said in the theory video, the stories they can come up with is extremely random. So in this case, it's a cyclist. So let's read the question. A cyclist rode from town P and stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented by this equation. Note, speed is the rate of change in distance. My original would be S of t, so not fx, but st. And that S stands for displacement if you study physics. I don't know where the S comes from. Okay, but that is distance. The derivative of this would be speed, and then the double derivative would be the acceleration of this cyclist. So there's something you can just study, but you don't get very many of these questions. But if you do, if you didn't know that little bit, then you could get stuck very easily. Question 10.1, calculate the maximum speed that the cyclist reached on his ride. Okay, so very, very technical now. If they ask me the maximum distance, I would get the first derivative and make it equal to 0. That's not what they're asking me. They're asking me the maximum speed. So then I must get the derivative of the speed function and make that equal to 0. And that's actually the one they started me off with. So I can then just write down the formula that they're giving me, and then I'm going to get the derivative of this formula. So the double derivative of this would be equal to minus 6t plus 18. And I will get the maximum speed if I make this green one equal to 0 and solve it. So I'm just going to take the 18 over. So t is equal to minus 18 over minus 6. And therefore t is equal to 3 hours. Now the question didn't ask me when he reaches a maximum speed. The question asked me what is the maximum speed. So now I can take that 3 hours and just sub it back into the speed formula up there. So the speed at 3 hours would be equal to minus 3 times 3 squared plus 18 times 3. And that would be 27 kilometers per hour. Okay, so very technical. You needed to know exactly into which formula to sub in order to get that answer. Question 10.2, calculate the distance between town P and T. Like I told you guys, distance is now linked to the original question. So the y values of the original function would be distances. Now, I need to figure out a lot of things in order to do this, and it's a 5-mark question. So let's first think of what's going on here. So this story starts when the person leaves town P. So if I think of x and a y axis, and x is hours, and y is kilometers. So this person started exactly at 0, 0, where time was 0 and kilometers was 0. Then the person probably rode somewhere and then stopped somewhere, and that would be, if this is town P, that would be town T. The graph would then turn again somewhere, but I'm not interested in that part. So I'm just interested in the distance from the x-intercept to the first turning point. So let's see how we would do that. First thing is I'm going to have to figure out what the two turning points are. And because I have the derivative, I can just make that equal to 0 and then see where this graph would be 0. So I'm going to start with 0 is equal to minus 3t squared plus 18t. From there, I can see I can take out negative 3t as a common factor, and I'm left with t minus 6. Therefore, t is equal to 0, or t is equal to 6. Okay, great. So now I know that the person reached town T after 6 hours, but I still don't know how far it is. So now I must first get the original function by doing the antiderivative or any other method that you like, and then to sub in 6 in there. And that is how I will then find the actual distance. So with these questions, if I then assume that there was a plus 0 at the end of my derivative, and that my original will also end on a plus 0 because town P represents 0 time and 0 kilometers, I can say the original function must have been at cubed plus bt squared plus c of t plus 0. Now, if I derive this, I'm going to get 3at squared plus 2b of t plus c. And now I can just use this in the blue function and correlate with the green function, and that's how I'm going to solve. So 3a will be equal to minus 3, and then 2b must be equal to 18. I can see that c is just equal to 0. So in this case, a would be equal to minus 1, and b would be equal to 9. So therefore, the original function had to be minus t cubed plus 9t squared plus 0 plus 0. And then to find their answer, how far are the towns from each other, I will just sub in 6 into that equation, and that's how I would find it. And if I sub that in and type it into the calculator, it tells me it's 108 kilometers apart. Okay, guys, so there was one of those questions where you really needed to think And I don't think in any textbook there was a question like this. So that's the trick with these questions in exams. You can study 20 of these sums and then they throw in something random. But don't give up. There's always hope, and maybe you are the year where they just give easy questions.
If this video helped you, please like and subscribe.
JMath.